All right, so we'll get started here. We have a 30 to maybe 40-minute panel, short panel on following up on all the excellent presentations that you just witnessed, ranging from extremely impressive, fully autonomous maritime vessels, which don't need any human supervision. I'm very curious to know how that works, and ranging from all the way to what are the challenges in AI when it comes to complexity that autonomous vehicles face and aerial vehicles face in hazardous environments like a nuclear reactor, leading up to some challenges in the security for autonomous vehicles, and the underpinning science of it all in terms of reinforcement learning or similar sort of challenges which make this autonomy which enable this autonomous behavior in the first place. So when I was told to have a panel, I sort of went with a clickbait title of how can we detect blind spots in AI, but actually I'm feeling pretty good about that because it's resonated very well with what all of you touched upon. And so I'll kick things off, but this is meant to be a very interactive sort of discussion and open discussion, emphasizing on some of the follow-ups on these challenges that you have presented and your opinions on what maybe is missing or what the academia can focus on and complement and really lead to some fruitful collaborations. Later today, after this open discussion period, we'll have very short sort of research highlight talks from some of the faculty in autonomous systems in the Link Lab, so you also get to listen to the sort of the side of things at our end. So let me kick it off with maybe a tough question to begin with, and as far as panel goes, I always like to get some bold and controversial statements out of the panelists. so let's start with this.
Does it have to be about autonomy?
So maybe let me start with, in light of what has recently happened in terms of the Boeing 737 MAX sort of crashes over there and the safety assessment and analysis leading up to that, to me it has become very important that the aviation industry you would consider would have a very strong grasp on autonomy because they have been at it for the longest amongst all other domains. And now we are witnessing things where there's a conflict between the autonomous AI decision making and an expert human. And so the question really is, in your opinion, what is the role of experts in the long run? And when it comes to fully autonomous vessels or even autonomous vehicles, there's a problem of graceful handoff. How does it tie into what sort of advancements do you think are needed from a technological point of view or a system design point of view to avoid such pitfalls where we do all this hard work and then it's not in agreement with what the expectation of the human is? So I believe there was a question somewhere in there, but I'll leave it open-ended and vague and just take a stab at your thoughts on what role do you see humans playing in all of this autonomy? And then others can join in asking more questions too.
You want to start?
Yeah.
So,
Okay.
so we have some work going on in what's called understandable autonomy, and it basically has to do with when's the right time to ask for help from a human, or when should the human intervene, right? And that the non-trivial part of that is who's better at understanding the mission, right? In my world, it's a military mission, right? We have, in most of our systems, we have what's called a safety critical function that says if autonomy loses its mind, we call it a lunchbox, actually. It's a piece of hardware and some software that's completely independent from the rest of the stuff that's on there. And if autonomy loses its mind and it can't reach a human, that box takes over. So, but in the meantime, autonomy should be asking the human. There's always somebody watching. What, am I continuing to do the right set of things? And when and how you do that, in a highly classified mission and denied environments where you can't get to the vessel very often is a non-trivial problem. Mm-hmm. And there are special ways that the military is looking at doing that. And maybe you only get a few bits through, right? So you have lookup tables on both sides to decide what the actions are based on just a little bit of data. And so I'll
Interesting.
start it with that.
Yeah, I want to follow up. We do almost exactly the same thing in terms of we have something called a watchdog. And because the challenge with autonomy, of course, is assessing a complex system and doing it in a way that's safety critical.
That's right.
Right? Because safety criticality requires some deep analysis of the code and of the systems. And, with an autonomous system, it's too big. It's infeasible to use standard techniques. Today's standard techniques, So the idea then is to have the simpler, separated system that's effectively interrogating the more complex system. The analogy I use is like we're on a 12-hour drive, and I just so you feeling tired, doing okay, need a break. Yeah. I'm not trying to understand him. I'm trying to understand, can he drive well? Right? And if I don't get good answers on a couple of those, I'm like, hey, let's pull over, we'll switch, or yeah. So that's sort of the idea, super simplified. But I think that is what makes sense. And going back to my slides, I think we do need the humans in the loop for the art side of it, right? You need the art. Autonomy is as much, if not more, about what to ignore than what to actually pay attention to, and that's the challenge. And that's what we been working on this for however many hundreds of thousands of years, as humans. So we're pretty good at that, and it's just a matter of being able to converse with the system in an appropriate way, right? Mm-hmm. So, there you got there.
Jump in. So, I guess one of my thoughts about it is how do we keep people being experts? So, look at the aircraft industry where you've got pilots, right? So they start to get dependent on autopilots, right? The autopilot's doing a lot of the work. Eventually, their skill set starts to degrade, and something comes up. Do you transition it to them? Maybe if they were the expert, are they still an expert? Maybe they were an expert 10 years ago, but their skill set is degraded a bunch. How do you keep that expert there and available and functional? And how do you keep that high skill level when we're putting a lot of this autonomy in place? So I think that's something that some of the industries are struggling with.
Yeah, and I think just to follow up, and by all means, feel free to, it doesn't have to just be a dialogue between me and the panel. The same problem I would imagine exists in sort of medical diagnostics, where the autonomous system is maybe just not a robot, but AI making some suggestions or diagnostic decisions. And it's plausible that over time the physicians are not, keeping at par to their skill level as well.
Become
I guess the sort of leading question is then, do you think it's better to not have the human in the loop at all, or?
I think we may get there, yeah, where it's, and actually I had a professor that described it as he expects that in a couple of years there won't be two pilots up in the cockpit. There'll be a pilot and a dog, and the dog will be there to bite the pilot if he tries to do anything.
So for us, it depends on the mission, right? If it's one of these dull, dirty, dangerous things where it's going out and just drilling holes in the water, going back and forth, you can imagine, you don't need to look in on it that often unless something goes haywire. But if it'll be a long time before we shoot somebody from a robot, right, in the military context. And so if you've got a vessel with weapons on it, it's always, for the foreseeable future, is always going to ask somebody who has authority and under all the right ethical rules of engagement and things like that, it's going to ask. It'll be a long time before we do that.
So you mentioned that the issue of making sure that people maintain their expertise,
Right.
or that people have good situation awareness.
Right.
And I want to come back to that, because even if people have expertise, you have to design the system so that they can maintain vigilance in such a way that if you have to do a real-time critical handover,
Right.
they can assess the situation.
That's right.
And react quickly.
Right.
I know the military has done a lot with that, but what are you doing in terms of the design of autonomous vehicles to maintain that vigilance and situation awareness so that somebody could take control without
Right.
sliding off the road?
That's a great question, because there's lots of studies that try to address how long does it take somebody to regain their situational awareness and be able to do something positive for the situation rather than something negative.
Right, and it's seconds.
And yeah, and even in good situations, it's seconds, it's many seconds, and can be minutes depending on how far you've drifted off.
Well, let me go provocative since we're going to play this game. I think it's good at what is the real question, because I mean, let's all troop over to the woods and try to start a fire with a flint and a piece of steel, right? Wasn't that long ago that was a critical skill for people, right, to have, because you might not survive. You couldn't actually light a fire with a couple of sticks or with a flint, and that's just gone, right? So, I don't think I could do it. I don't know how many people in the room could, but does it matter anymore? To the extent of, systems that get, when we have these triple, double, triple, quadruple redundancies, and the systems just have good controls, do you really need to be a pro driver? You're going to come down to where the system is going to manage the situation, and you're just going to give it guidance about, yeah, I think you're right. Why don't we pull over and we'll wait for somebody to come look at you because there's something wrong here. But it can handle everything to that point. So it's more about guidance, I think, because I think that if these systems, and these are pretty good today, right? We're already doing a pretty decent job, plenty to do, but the pace is fast. And, another decade or so, it's like, why would you drive? I mean, and from the people in school, I mean, my daughter, she's like, whatever, I don't want to drive. If she could get driven around, she'd be happy as a clam, right? And that's just the way it is. So it won't be that long before, because, and you can look at the Industrial Revolution, the skills required to keep an older piece of machinery running, just like, like a clockmaker, right? And that's just all gone now. Nobody knows how to do that anymore.
And I think part of that, I kind of mentioned in my opening this morning as well. The designing systems to support multiple different generations at the same time. And I was talking about, will my daughter ever have to learn how to drive? Maybe
Yeah.
not. And even if she does, or I always get back to your research about a driver in our age category in an autonomous car feels risky when the car drives too close to a median or does things that if you were operating it, it feels risky to us, right? Whereas if you had never driven your own car fully manually, you wouldn't care, right? So you may care less because you don't have that learned behavior of a manual driver of what that risky behavior might look like, because it's not risky anymore. So I think part of the challenge going forward in the design of systems is how do you design for the people that are grown up in that world where it's natural, the transitory generation where we've some in, some out, right? And then the other generations that, like, no way is some computer ever gonna, am I gonna have one in my pocket and call people on a phone using it? I mean, that's, I think, part of the genius of the design and how we work through that period, because every generation will have that kind of mechanism. So,
Yeah, it reminds me of a quote from this book called Hitchhiker's Guide to the Galaxy. It's a very famous book by Douglas Adams.
42.
Yeah. So the quote says that anything between sort of 0 and 15 years of your age is the natural scheme of things, and this is how the world works for you. Anything between 15 to 30 is something that you can probably get a career in, and anything invented after 30 is against the natural law.
That's right.
One thing in my world is that where autonomy helps you, or AI or machine learning, is if that system, if it's assuming it has all the sensors, right, that it can do everything a human could do, it can make the decision faster. That's better, right? If it can do something safe more quickly, or amongst the different sensors that it's fusing together, it can see correlations in that data that are useful that a human can't, right? But if it can see, hear, smell, and do all those things and correlate them the way we do, it might get to the same decision, but it'll do it faster. And that's, a lot of times in military systems, that's a huge benefit, right? And you're not putting anybody in harm's way to do it.
So I'm thinking of this sort of from an academic perspective, and what I would ask a PhD student, so that they can graduate is like, what does it mean to have solved this problem, right? And then it's like, well, this is an unsolvable problem. in a sort of scientific way in some sense.
So, yeah.
But then my question is, what does it mean? We all come with our own connotation of what it means to solve these problems. And so, for example, if I would have asked you if I would have asked you last year at this time, is aviation safety solved? Commercial aviation. Everyone would say, yeah, it's solved, at least in the developed world. And does 2 accidents in a 737 MAX negate that? Maybe it does. But there's
It's a big step backwards.
there's a perception and cultural and sort of, there's a human element to all this.
Yeah.
And
Yeah.
what does it mean to say that autonomous cars are ready to go? And depending on your age, I think you would answer that. And, you know, they've done studies on this now. And so I guess I haven't answered a question there either.
So
It's
I
like
can
you
frame-
kind of, but,
Yeah, so the- but-
there is a yeah, go ahead.
Yeah, so I think you brought up a good point, and maybe this can lead into the question you had in mind, right? So, you know, maybe Bharat, you can also, since you just jumped in from academia to Amazon AI labs, and you know, you're looking at the sort of a good perspective on both how academic research works and now how the industry progresses. So maybe I think what Cody was trying to get at some point is what in your view is missing in some sense from academic research in autonomous systems, cyber-physical systems, and AI? And another way to rephrase that question for the others is what major sort of breakthrough are you looking forward to in autonomous systems, right? So what is that? The field itself is such a field where we've had these seminal events, you know, from 20 years ago when you beat Gary Kasparov, chess champion, to now AlphaGo, and even other sort of very hard perceived challenges. So what do you think this next big moment for AI might be or to be? Yeah. So a bunch of different questions in there. If you can shed some light on what academia can focus on and what do you think is a grand challenge?
Well,
Yeah.
so AI or CPS or
Autonomous systems. I think they are intertwined at this point. So.
So let me just give a comment on the human in the loop
Okay,
system, and then I'll answer your question. So there was a diverse viewpoint, and one of the things, the way I think about autonomous systems and humans is that no matter how advanced we go, the human will always be important. And if an autonomous systems wants to be really good, it needs to understand the human. So it needs to understand their age, what their experience is, what their reaction time will be, what can the autonomous system flash so that the person does the right thing at the right time in order to be effective. So I think that is a really big challenge, and I don't see as many works in this. Like in airlines, there were studies on how a pilot almost always misses the LED blinking in a critical situation if there is hours of boredom in between. So those kinds of direction I think would be great. In terms of grand challenge breakthroughs, I think it's the opposite of something we want. Like we can close our eyes and completely rely on the system, and if we work with that 99.9999 reliability and robustness, and regardless of the situation you're in, that's what we want from an AI. And once that happens, you know, everybody just uses it. The tools to abstract it out becomes much easier to make, and things work better, I think.
Any other thoughts?
So I won't say what car company it was, but it's related to your guys' work in the cars. I was at the NASA Space Autonomy Conference a few years ago, and a guy that was in charge of autonomy for a particular car company. And we were talking about how do you get human behavior, because that's the next big thing, I think, is if you can program human behavior, which is really squishy. There's a few absolutes that you'd like it to do, but then, you know, there's a whole bunch of right answers when it comes to human behavior. And I said, okay, the car's going to crash. It's going to hit something. It's going to hit the truck in front of it, or grandma with the walker on the right, or a woman with a baby stroller. And maybe there's a baby in the baby stroller. It's going to hit one of those three. Which one do you pick? And he said, right now, I picked the thing with the smallest number of pixels. And I said, really? And I said, there's no human decision in that. And that's when it got brought home for me that a lot of times this is it's math, right? And cost functions, and you make a decision, but there's no assessment for risk or the how much is a life worth? How much is the truck worth? And all of that factored in yet. So somebody that figures that business out, it's going to be a big deal.
Well, I think, back in controversial land, I think that that's a great point. It is a great point. But I think that the trolley problem for me is just such a false, I can't even think of what the right word is for this thing, but it's the biggest thing to consider is that these systems are monitoring everything so quickly. Back to the earlier point, our slowest cycle is 1/10 of a second every assessment, or it goes up to less, to 1/100th, and less time. And the bottom line is it's not like you're just going to fall out of the sky and suddenly, there's grandma and there's the nuns and there's the big rock, but accidents do happen. It's a physical world, right? So physics still works even in autonomy. If a rock falls off the hillside right in front of you, you're gonna hit it. And what the car will do, of course, is slow down as fast as it can. And if it should have some notion of vehicle dynamics, and it will probably try to steer a little bit. But after that, there you are, right? I think that there can be and should be some useful work in trying to assess what's the best choice to make here, right? And that is where you can do a lot of refinement, right, for years, to look at what makes the most sense, what's the minimal way to get injury or damage out of this. But sometimes there's not a lot of choice. You just take control. Just quickly on the audiences for autonomy, last year we went with SAE. We did a variety of public road trials. You can see some of that on our website. And we gave people rides all week, right? We went to a highway in Tampa, where we went 55 miles an hour down this highway and back. And then we went through this neighborhood called Babcock Ranch. And the number one fans were the elderly people who were like 70, 80 years old. One guy was 95. And they loved it. So they actually knew a lot about it. And why? Because it's my worldview, which is economics drives everything. These guys are all looking at this from the problem of they're not going to get their license, and they're going to be trapped.
Car still.
So they're like, I'm hopping in this puppy. I don't care if it makes me a little sick. I don't care if it's a little. I'm getting in this because that's the only way I'm getting around. And so they'll put up with a lot to do that. So the elderly people are on board. So actually, they're not the problem. Back to the earlier point, it's maybe it's us. Like, ooh, I don't know. But anyway, just based on your perspective, how you see it.
Yeah, I agree. The human acceptance is an enormous part of it, and also the problem. I mean, the scale of the problem. Like for us, if we insert a vehicle, it doesn't work right the first time, it works right the second time. That's great. So we have 50% failure, but we got what we needed to. It wasn't a high risk situation. We weren't worried about people's lives and things like that. But you look at things like on-road autonomy, where you're talking about hundreds of millions of miles. Even if you have one bug that kills somebody once every million miles, that's still going to happen all the time, and that's going to be unacceptable to most people. But where do you draw that line where it's like, hey, it's we're saving more lives than are being lost by doing the autonomy. But then you get into people.
People do we lose every day from distracted driving?
Right, absolutely.
So these safety systems are
right.
ready,
I
but
totally agree.
When they fail, it's a big step back for the industry.
Absolutely, and then it comes back to a person would have never made this decision. The autonomous system made a decision that costs a driver their life, passenger, whatever, or an injury, whatever it happens to be. It made a decision that a human wouldn't have made, and that one time is going to set back everybody enormously. Yeah, even though all the times that a human would have made the mistake and all the times that a person would have lost their life, the system saved those people. We still have a tendency as humans to look at that one where it's like, I would have not done that.
But just quickly, I would challenge that only because we've already been here. I mean, we already had the Uber car already killed somebody, and I was like, oh, here it comes, And what? Nothing.
Yeah,
right?
I was gonna say
like,
that could be a little overblown because who's flying out of here tomorrow? Mike's flying to Australia tomorrow.
Right.
He's not worried about about Boeing.
Right.
So there is sort of like when you sit down and think about it concretely, we have all these spooky thoughts, but then if you actually observe human behavior, I don't know that it actually changes.
But this is a good segue into the security issues, because you talked about attack vectors, but one attack vector that wasn't, or at least I didn't see up there, is supply chain issues. So if I can take over, in one spot, get into, Progressive's warehouse and change those in such a way that I can take over a car, I can cause a massive attack. Not me, I would never do that. But somebody could cause a massive attack. And we're not talking about a single individual. We're talking about a real calamity, right? And so are any of you, I know the military looks very carefully at supply chain, but in cases where you have third-party components, this is a real problem. It's a big exposure. And the danger isn't that you're gonna have one accident or if there's a slight bug or a misrepresentation of some problem. The danger is that you can have a massive problem because of the scale in which these components are used.
I have a follow-on to that, that has to do with sort of standardization. And it's not just a cybersecurity topic, but I wonder, is standardization the answer to that? Because I would say you might say diversity is better.
Right.
If it's diverse, if the supply chain is diverse,
Monocultures are dangerous.
then maybe, and I know that's not exactly what you meant with standardization, but
Right.
if diversity in the autonomy is better for safety and security and all these things. Because otherwise, if it's truly standardized and I can take down one function and I take them all down, right? Have you thought about that? I'm looking at you just because you talk about
Yeah,
this.
I've looked at the diagnostic systems that interface, the factory diagnostic systems that every manufacturer has. They're typically tied to a server. Now, if that server was compromised, their whole, every vehicle on the road that gets an over-the-air update could be compromised. Supply chain, we look at counterfeit chips, things of that, that type of, industrial espionage, and if these engine ECU is made in a country that doesn't have rules and regulations as far as security goes, there's your issue right there.
Right, something comes from China, goes through Turkey, and comes to the US, and there are issues. It happened.
So one related aspect, since standardization was brought up, and we saw some glimpses of that when Tim, when you were presenting, you said there's rules and laws to how you can navigate on the ocean. It's not a free-for-all ride. And so it seems like, just like the aviation sector, there's been a lot of thought given into what you could describe as the specification of operation on a road. And some of them applies to autonomous systems. But I'm curious, because this also maps to autonomous cars, where there's, I would say, a rather loose notion of safety, if there is any notion at all. There's no consensus yet on, as Cody pointed out, what's a safe vehicle. But to the panel, I want to ask, do you think that how can the autonomous behavior, since you talk about going beyond on designing vehicles and ships which are not meant to house any humans, so they can be designed in a separate manner rather than fitting the existing sort of chassis in that sense. So when we try to push towards that limit of what is feasible with a fully autonomous behavior, I would imagine it would conflict with many of these existing rule sets because they weren't designed with that sort of a mentality in mind. But then you also run the risk of, if there's too many sort of rule sets, we'll never get to any kind of consensus as well. And I think that's what's happening in the self-driving car space, where everyone has their own notion of self-reporting voluntarily how safe their cars are. So how do we resolve this conflict? And you think that is this something that academics can contribute to rather than just focusing on the technology?
So for the self-driving cars, I think they're almost always intended except for trucks and things like that. They're intended to have humans on board, but the autonomy's there really to reduce risk, right, and make it more predictable. In my case, I want to get people out of there, and I have to do a mission, but I don't want people around to do it. So you could probably come up with very different evaluations of risk and how you implement the cost functions and how you sense and all of that sort of stuff. It's probably very different problems, right?
And let me ask then, what do you think would be the potential for change over in those trade-offs, or in those objective functions over a long life cycle? And do you see that as an issue?
Well, I can imagine, again, I've only thought about it for about 30 seconds, but for cars, there would just be absolutely, with people on board, there would be absolutely things that you would never do.
Yeah, I'm,
Right.
I'm thinking potentially more of military situations
But-
where your perception of what's acceptable
Right.
changes over time.
Right, it changes over time and it changes with the mission, right?
Right.
And the stage of the mission that you're
In
in.
the context.
In the context.
Yeah.
And we've often thought about the guy who's watching, sitting in a brick building watching what's going on, even though he's not telling the robot what to do, he might have a risk dial, just very simple. I'm willing to get up close and personal with somebody now, or it's peacetime, I'm going to dial back and be very safe. I don't know, but you can imagine you might take a different approach to the problem.
Well, I think just extending that further and to mutter your point there, I think what would be useful is work on how to have a good conversation, right? So this is where you cover your lifespan as well, because you've got cars, we're already mostly connected. They would, by definition, be essentially for autonomy, because you're going to want to talk to infrastructure to make it all work better. And you've got also vehicles that have a lot of information. They know a lot about where they are and what's going on and what they're trying to do. And so what's the conversation? I mean, it could be that you're on a regular road and it's morning rush and they all talk about it and decide that both lanes are going to go into town, for this one stretch. And people that want to come that way will go the other way. That's a perfectly good conversation from my perspective. And, how do you have that conversation? Yeah, and how do you sort out what's a reasonable thing to do? Or even as much as like I call it the classic, but it's like the MIT video. You've probably seen the intersection where the cars just go at speed and they all just tweak their speeds a little bit and they just zip, 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 That's another great conversation. No more stoplight, no more stop sign, just work it out. But, there's a lot of security involved, but how to have that conversation, what to talk about, shared context, which is the fundament of language. Things like that would be interesting.
2 weeks ago, I was on a panel with the automotive manufacturers, and they were discussing, the different, the financial, aspect of what they want to implement in these cars. The struggle between 5G LTE and DSRC and all these, and how much is it going to cost to do this one versus that one? I mean, we got manufacturers dodging, the IIHS ratings. They switched the crash offset because manufacturers were putting more metal on one side of the car versus the other. So
That's
IHS said, we're going to crash test the other side.
Yeah, work
Boom,
the system,
1-star rating instead of a 5-star. So, it's, the manufacturers are playing, financial games with, essentially, lives of people riding in their vehicles. So,
it's the system, right? They're working within the system.
How are they incentivized?
Yeah, so it's economics again, right? So it's how do you, So I mean, again, what is the appropriate system? That's more fair, more equitable, I suppose.
And talking about legislation a little bit, legislation is actually working its way towards helping for some of these autonomous systems. I know with some of the convoy stuff we're doing with the trucking industry, trying to get convoys of trucks for fuel savings, ride right on top of each other. There are states that don't allow trucks to be within a certain number of feet of each other. So you can't even do any testing. You can't do anything in those states. And those states are actively talking to automation people and robotics and trying to decide what's the best way to change these laws so that they can be taken advantage of in the near future.
And then we have the political side where how many jobs is that going to eliminate from truck drivers?
Right.
So then we have, people like, oh, well, we implemented platooning in our state, but that also lowered the job numbers by a percentage.
Right, and then you get discussions with
And-
unions and also,
Right.
yeah, yep.
You know, in Norway, I recently learned that the insurance companies and the government got together and said, the risk of all of these people on our highways and all the mountains, and it's just too high, right? So we're going to do autonomous ships off the coast, and we're going to have a highway up and down the coast with just autonomous ships moving things back and forth, and we'll leave the highways to, people and families driving in cars. I thought that's pretty cool,
Yeah, that is.
but it's a huge investment for them.
So one thing that I thought of a second ago when you were talking about, the wrist dial, and I was thinking about your talk where you take a mission profile that's sort of in the language of a captain or something, as I understood it.
Yep.
And I think that that's a really interesting notion. So everyone talks about explainable AI, and they mean, can a human understand what the AI is doing? But it goes the other way.
It does.
It's like, how can you get the machine to understand? I think you're kind of alluding to that too. And I think that's a big question in, no matter what domain you're in. If it's as simple as a wrist dial, but it could be more complex than that. It could be.
Well, it might be one dial, but it's tweaking 1,000 parameters under the hood that you don't see.
But do you understand
What
what
that
you're
implies,
doing when you're
yeah.
doing that? Or if you say something richer in sort of natural language, can the machine interpret that in the way that, or if you see something that that is sort of even outside the feature space of what the AI was even trained on, it's like, there's a person on the ship waving his hands like this. That's not in the code regs.
Nope.
But it's something that that you could have never trained on. Can the machine interpret something like that? Or in the case of autonomous cars, it's like, you got a pregnant woman in the car and they have to get to the hospital fast. Right? Like,
Well, that point you just brought up is one of the challenges that I'm facing right now with the systems that are currently available on late model cars. A tactical driving scenario. There's a roadblock. I need to go through that hedge road to evade, some threat. This system won't let me do that. So how do we, how do we do that? How do we juggle those
and
requirements?
we'll figure out a way. Humans are good at sort
Right.
of hacking their way through, we all do it
That's
with our
right.
phones.
You were asking a question about a counterfactual, something that you've never trained on, and saying, if I had done it differently, what would have happened?
Right.
Machines are very bad at counterfactuals.
All right,
Humans are
exactly.
very good at it. Well, reasonably good at it.
Yeah, because we can lay out a few different models that
Right,
just
right.
out of left field and go, well, I probably should do that in this case because,
Right, but we have the concept of counterfactual.
Mhm.
Machine learning, it's very hard to do that in machine learning.
Exactly. Well, that's why, again, that's exactly why we like the consultative approach, as it were, so that no matter what, it will drive fine, but it can drive better, when you can get some additional information.
I think it'll be fun to see how people get trained too, because
Yeah.
as autonomy becomes more pervasive, we'll know how the autonomous systems react in kind of situations, and we'll change our behavior. So instead of doing this, maybe we're doing this, or any number of things, right? So it trains us on how
Yeah.
we should interact with it.
The robot
Because
language.
sometimes what the human would do is not the right answer,
Right.
right?
And I
Because they
wonder
haven't
if-
been trained well, or
I wonder if we
don't
can
understand.
learn from, in the autonomous systems world, I wonder if we can learn from sort of more mature, air quotes, more mature areas of AI, like even something like Netflix. It's like, how have people changed their behavior because of this recommender system?
Right.
And sort of bake that into how we design our cars. I don't know what I'm talking about.
Right, a whole area of research all amongst itself, right?
Yeah.
All right, so we are going to wrap up this session right now, but since you're here, I want to tell you that, we want to have more conversation, and this is only a short span for this open discussion. So we'll have a closing reception at Cardinal Hall, and I encourage everyone to go there and continue these discussions. I want to preserve, in this action-packed schedule of ours, some time for you and everybody here to get to know some of the stuff that the faculty in autonomous systems and the Link Lab are also working on. And so just like the nature of the work that you showed here on ocean, sort of water-enabled autonomy and aerial vehicles and self-driving cars. We will have talks, very brief highlight research talks on autonomous vehicles, underwater vehicles, medical robots as well. So I always like to do this, being a roboticist at heart. This is something I always ask people who work in autonomous systems, and maybe this is a very fast way to close the panel, but we can go one at a time in order or however you feel. But what's the most impressive thing you have seen a robot do that you were like, wow, and it cannot be your own product? So maybe you can share that with us to conclude. Wow. What did you see recently which was like, wow, this is what an autonomous system should be able to do?
I think for me, the biggest kind of recent wow moment would have been at the Olympics, where they've got all the UAVs up in the air, and they're not just creating a static image, they're actually creating an image that moves up in 3D space, and which was amazing to watch. So that was kind of a wow, that's really cool, and kind of knowing, behind the scenes, what did it take to make that happen?
Yeah, and I think just the sheer sort of engineering behind it is.
Oh yeah, the scale and the engineering, oh yeah.
Any other examples? Yeah.
Now I'm trying to think of one.
So I've seen recent examples of robots doing things which takes like 4 hours of machine learning training and does about the same kind of things, like you kick a 4-legged robot and it stands up, and that took decades for us to get it work, and Boston Dynamics.
Yeah.
So there is an equivalent robot I saw a month ago from AT at Zurich, where they trained it in 4 hours and it does the same thing. So it was very impressive, and it's just that I don't think, at least personally, I can't comprehend how fast that progress is happening, and it's hard to imagine where it would go just in 2 years from now.
I mean, the one thing that I think of, it's a little older. It's a couple of years ago, I think they did this, but they, and it just, for me, it impressed me with the level of controls. They had 2 drones set up where one would balance a rod on top of it, and then it threw the rod to the other drone, which caught it and balanced it.
Yeah.
And I just, for me, that just, that's a silly exercise in what, but I mean, it's an exercise in control, which is, I'm like, wow, they could do all that processing in that time and pull that off. That told me, okay, we're at a place where these things can do quite complicated actions.
Yeah, that's actually a very impressive video if you haven't checked it
It's
out.
an exercise in Photoshop.
It was quite good then.
So I struggle with the so what on this one, but a friend of mine, a fellow named Nahid Sitki, who was involved in the early phases of Sea Hunter, I can't remember the name of the company he went to, but they were doing a contest, and it was a human robot, right, to mimic human behavior. And this is related to the car thing, where the robot opened the car door, got in, sat down, and drove the car. It was a normal car. So it was an autonomous car, but it was a robot driving it.
Yeah,
And I
that
thought, sorry. And I'm like, okay, what's that for? So maybe it's the driving the elderly people around, but they get to use their car instead of buying an autonomy car.
And Darren, maybe for you, any examples which come to mind, which when you looked at that and alarm bells went off, that not secure at all?
Yeah, as far as security goes, it's every day. Margot and I recently went to a JTAG class where we were soldering hair wires under a microscope to pull the data off a chipset on an Amazon Fire Stick so we could look at what was being watched and their user accounts and all that kind of stuff. Cool. So the data that resides on just something that you think is dumb can solve crimes every day, every single day. It's always listening, it's always on, it's always collecting data, and it's waiting for something to happen, and it's going to be used against you at some point.
And that's the upbeat note. We're going to close this session.
Let's hang out for the time. Thank you so much.
Thank you guys.